Good morning. I am Dr. Y.MANJULA Devi, working in KSN Government Degree College, Anantapur. So, title of the paper is Inorganic, Physical and Organic Chemistry, that is paper 5. In that paper 5, so the title of the topic is Coordination Chemistry. In Coordination Chemistry, I am going to discuss Sidgwicks theory for a complex compounds. So Sidgwicks theory or electronic theory. So Sidgwicks theory is also known as electronic theory. So actually he concentrated on two things only. So especially he concentrated on the nature of bond between metal or metal ion and ligand. So what type of bond is existing in between metal or metal ion and ligand. And the second thing is he concentrated only on the stability of the complexes. So in that first one, the nature of bond between metal or metal ion and ligand. So according to him, complex is formed by the donation of electron pair from a ligand to metal or metal ion. So complex is formed by the donation of electron pairs from a ligand to metal or metal ion. So that means a ligand will donate electron pair towards a metal or metal ion. So thereby complex is forming according to Sidgwicks. Next, ligand. So a ligand must contain ligands which coordinate to metal atom have at least one pair of electron. So according to Sidgwicks, or according to him, he explained ligand as a electron pair which is having a electron pair in it. So ligand, according to Sidgwicks, he explaining that a ligand is a electron having a ligand must contain at least one electron pair. Ligand means at least it contain one electron pair. Next, if all ligands supplying electron pair, so ligands according to Sidgwicks, they are donating electron pairs towards metal or metal ion. That means ligand must contain at least one pair of electron. So ligands are electron pair donors. According to Sidgwicks, ligands are electron pair donors, and metal or metal ion, they are accepting from the ligand, thereby the complex is formed. So according to Sidgwicks, metal or metal ion is electron pair acceptor. So according to Sidgwicks, metal or metal ion is electron pair acceptor and ligand is electron pair donor. So generally in between acceptor and donor, a coordinate covalent bond will exist. So according to Sidgwicks, in a complex in between metal or metal ion and ligand, a coordinate covalent bond is existing. So if you take example, diamine, dinitro, dichloroplatinum complex. So in next slide, we are observing that in between platinum and ligands, so we observe a coordinate covalent bond. So here the ligand nitro or chloro or amine, so they are donating electron pairs towards platinum. So that will be indicated by a arrow mark. So from ligand to metal or metal ion, that is platinum, so arrow mark is arranged. So according to Sidgwicks, a coordinate covalent bond is existing in a complex. So next, so Sidgwicks, he also explained the stability of the complexes. So stability of the complexes is explained by him. He actually on the basis of effective atomic number, that is on the basis of EAN rule, Sidgwicks explained the stability of the complexes. So actually what is meant by EAN? So effective atomic number. So what is meant by effective atomic number? So the total number of electrons in a complex, that means the number of electrons in metal or metal ion and the number of electrons accepted by the ligand. The summed value, if it equals to the next incoming inert element atomic number. So the total number of electrons, that means the central metal atom, the central metal atom, number of total electrons in central metal atom, and the number of electrons accepted by the ligand, the total summed value, if it equals to the next incoming inert gas element atomic number, that number is known as effective atomic number. So the total number of electrons in a complex, that means the sum of the number of electrons in metal or metal ion and the number of electrons accepted by the number of electrons accepted by the ligand. So the summed value, if it equals to the inert element atomic number, then the number is known as effective atomic number. In a if a complex, if it obeys EAN rule, so according to Sidgwicks, if a complex it obeys EAN rule, so that complex is highly stable. If a complex if it not obeys EAN rule, the complex is unstable. So according to Sidgwicks, if a complex obeys EAN rule, so it is highly stable. A complex which is not obeying EAN rule is unstable according to Sidgwicks. So this is the theory for a complexes. So Sidgwicks he concentrated on two factors or two things. One is the nature of bond between metal or metal ion and ligand, and second thing is the stability of the complexes. So here we are taken one example, that is hexacyanoferrate 2 complex ion. Hexacyanoferrate 2 complex ion, in that iron. So iron actually atomic number is 26, but in this complex it is in +2 oxidation state. So 26 minus 2, that gives 24. So 24, and here the number of ligands are 6 ligands. So they are each ligand will donate 2 electrons. So 6 into 2, the multiplied value is 12. So 24 plus 12, 24 plus 12 gives 36. That means 36, it is krypton noble gas element atomic number. So according to Sidgwicks, hexacyanoferrate 2 complex ion is highly stable. So next, so what are the drawbacks in Sidgwicks theory? So here we studied the postulates of the Sidgwicks, but here number of drawbacks are observed in this theory, especially when a ligand will donate number of electron pairs towards metal or metal. According to Sidgwicks, a metal or metal ion is accepting electron pairs from ligand. So by accepting number of electrons from ligand, the metal or metal ion surface will be accumulated. The negative charge will be accumulated on the surface of the metal or metal ion. By accepting number of electrons, here in last slide we observed that in hexacyanoferrate 2 complex, 6 cyanoligands, they are donating electron pairs, that is 6 electron pairs are donated by 6 cyanoligands. So overall 12 electrons are accepting from cyano according to Sidgwicks. So donation of electron pair, so 6 into 2, 12 electron pairs are accepted by the 6 cyanides. So by accepting number of that is 12 electrons, thereby the iron surface will be negative charge will be accumulated on the surface of the iron according to Sidgwicks. When if the negative charge will be accumulated, the complex stability will be a question mark. So the surface of the metal or metal ion will be accumulated by a negative charge. So that is not happening in the complex. Complex actually it is highly stable. So for that question, the Sidgwicks theory is not explained. Next, many stable complexes, especially hexacyanoferrate 3 complex. If we take hexacyanoferrate 3 complex, it is a highly stable complex, but it is not obeying EAN rule. So even though it is that hexacyanoferrate 3 complex, it is not obeying EAN rule, but it is highly stable. So why that hexacyanoferrite 3 complex is stable? So for that question also, this Sidgwick's theory is not given any answer. So next, this theory fails to predict the type of magnetic property or the type of orbitals which are involved in the bonding. So it does not predict the magnetic properties of the complexes. So complexes either they are exhibiting magnetic property or not, that and all will be not explained by this Sidgwick's theory. So next, this theory fails to explain the geometrical shapes of different complexes. So for coordination number 2, for coordination number 3, for coordination number 4, coordination number 6 complexes. So what is the geometry for those complexes that are not explained by this Sidgwick's theory? So very important drawback is how a electropositive metal or metal ion is accepting electron pair from ligand. So metal or metal ion is highly electropositive in nature. So how a electropositive metal or metal ion is accepting electron pairs from ligands? So for that important question, the Sidgwick's theory is not explained any answer. So how a electropositive metal or metal ion is accepting electron pairs from ligands? So for that question, so Sidgwick's theory can't explain. Next, so according to Sidgwick, he explained that ligand must contain a electron pair. So ligand means it is a electron donor. According to Sidgwick, ligands are electron pair donors. So which type of electrons are donated? So if we take example amine NH3 or H2O aquo, so here the s orbital electrons are donated by that NH3 or H2O ligand, that is amine or aqua. So it is donating NS electrons. So NS electrons generally they are highly stable. So NS electrons they are highly stable. In ground state they are highly stable. So to donate that electron pair, so that ligand must get excitation. So then only that electrons will be donated by that ligand. So generally for excitation we have to supply some amount of external energy, but in complex formation we are not supplying any external energy. So we are not supplying any external energy. So for that question also Sidgwick's not explained. Next, this theory fails to explain the type of electrons which are donated by the ligand, especially 2s electrons. Generally they are highly stable. So in ground state they are highly stable. So then after excitation only they will be donated. But for excitation we are not supplying any external energy for the formation of complex. So for this question also Sidgwick's theory is not explained. So next. So this is about my topic, that is Sidgwick's theory for complexes. So thank you.